Okay, I'm going to do SI units, but I'm doing it as a maths topic, but actually it cuts both true maths and physics, right? It's going to be relevant for math students and relevant for physics students also. What is the meaning of SI units? It's actually International System of Units, but it's in French. That's the reason why it is SI, not IS. In French, it's System International Units. I'm just trying to speak French, even if it's like I'm right? That's why it's SI units. But this came out from what? From measurements. As a physics student, if you're a physics student, you know that measurement is one of the most important topics in math. Not in math, in science generally. Measurement, because anything that you cannot measure properly, you cannot establish. Do you understand? And measurement, there are two things that we talk about, two things are relevant: the quantity and the unit. So what is the importance of units? Units are used to identify quantities. Units are used to what now? Identify quantities. What is a quantity? I can have things like mass. Mass tells me how heavy it is, right? I can have things like length. And mind you, I've said several times, so when I was teaching measurements from the physics, I said, what is about length here? Length covers for, yes, it covers for distance, it covers for radius, it covers for as long as it's a one-dimensional, okay, as long as you're measuring one point to another on a straight line, on a line, not necessarily a straight line, is what now? It's going to be length. It could be the circumference of what? Of a cycle. It could be the perimeter of the shape. It could be just all of those are what now? They'll classify under length. Radius, height, thickness, depth, all of that. Because under length. Take note of that. Then we have, let me use time and stop here. I'm not going to wait, it is far, right? Now, if I written something like 40, and I didn't write anything attached to it, I just wrote 40 as magnitude, as size, you'll not be able to tell what quantity I'm talking about. However, if I'm written 40 meters, you know what I'm talking about is what now? It's length. You understand? If I've written 40 seconds, you know what I'm talking about is what now? It's time. If I'm written what now? 40 kilograms, you know what I'm talking about is what? It's mass. So the unit helps to identify what now? The quantity. Is that okay? Unit helps to identify what? The quantity. So the unit of mass is kilogram, the unit of length is meter, the unit of what now? Of time is seconds. So I've established this. Let me go a little further. Now it's so important, especially in physics, that if you don't attach units to your quantity, they will mark you down. You will not get your answer correctly. Do you understand? So units are very important. And then also, we have higher units and then we have what now? Lower units. We have multiples and submultiples rather for these units. I have said in physics that the basic unit of mass is supposed to be what now? Gram. But because gram is too small, it was agreed that kilograms should be what now? Used. Right? So we have basic and then we have higher units as well. Let me run through that. Take note, SI unit is standard, is accepted generally all over the world. I don't want to go into so many history, so let me go to what concerns us. So for multiples for units, we have things like deca, we have hecto, and then we have what now? Kilo. This one is going to be what? 10 raised to the power of 1, 10 raised to the power of 2, 10 raised to the power of 3. So you realize that to go up, right, you multiply by 10 to get next, 10 to get next in that order. Alright? Then if we're going to get for submultiples, submultiples, we have guys like what now? Like deci, we have centi, and then we have milli. These are not all, but these are the common ones. Deci is 10 raised to the power of minus 1, centi is 10 raised to the power of minus 2, and milli is 10 raised to the power of minus 3. Alright? So it's like you are, to get the one on top, you multiply each of these by what? By 10 to go up. Alright? Let me now put everything together quickly. Okay. So if I was talking about length, for example, if what I'm doing is length, the basic unit of length is what? That's a meter, right? So if I'm going higher, I'll get this like what? Like decameter, hectometer, and what now? And kilometer, right? And kilometer. If I'm going downwards, I have to like what now? Decimeter, centimeter, and millimeter. Shorts for this will be written as what? KM. This one written as what? HM. This one written as DM. This one written as what? M. This one written as what? DM. This one written as what? Centimeter. And this one written as what? Millimeters. This is what we mean. These are multiples, these are what now? Submultiples. Is that right? For length. Having established this, the next thing to tell you is that if you are converting a larger unit to a smaller one, you what now? You multiply. As you're going down from a high to what now? To low, you what now? You multiply. If you're going from what? From a small one to a higher, you do what? You divide. If you're coming from a bigger one to a smaller one, you what now? Multiply. Smaller one to what now? Bigger one, you divide. Let me give you an example. Okay, let's say I want to convert 3 kilometers to meters. I'm going from what now? From higher to what now? To smaller. I'll show you what the conversion factor is in the next phase. But the conversion factor from kilometer to what now? To meter is what? It's 1000. Right? So since I'm coming what now? Down, I'll do what? I will multiply. So it will be 3 times what? 1000. So give me what? 3000 what now? Kilometers. However, if I'm going from what? From millimeters, let's say I have 45 millimeters, and I want to convert it to what? To centimeters. I'm going what? Up this time around. And the distance between what? Sorry, the conversion factor from millimeter to centimeter is what? It's 10. So if it's 10, it means that what? I'm dividing this by what? By 10. 45 divided by 10, so give me what? 4.5 what? Centimeters. That means that 3 kilometers is equal to what? Oh, sorry. I made a mistake. I need to show you. 3 kilometers is equal to what now? 3000 meters. And then 45 millimeters is equal to what now? 4.5 centimeters. Now, let me go further to conversion factors and all of that. Take note, if you are coming from up, down, you what now? Multiply. If you're coming from down, you're going higher, you what now? You divide. Let's see this. So, this is for length, mass, and what now? And time. I said what? When you're going down, you what? You multiply. When you're going up, you what now? You divide. Alright? So what's the conversion factor for each of them? From millimeter to what now? I told you earlier on, you multiply by what? 10, 10, 10, 10, 10, 10. So to move from one to another, you multiply by what? By 10. Is that okay? The same thing happens here. This is what? Milligram, centigram, decagram, gram, decigram, gram, decagram, hectogram, and what now? Kilogram. That's for mass, right? Then we have seconds, minutes, hours, days. This follows the same order for 10, 10, 10, 10, 10, 10, right? But this one is not following that order. From seconds to what? To minutes is 60. 60 seconds to give you 1 minute. 60 minutes to give you what? 1 hour. 24 hours to give you what now? 1 day. Now let me try 1 or 2 things before I leave this place as quickly as possible. Alright. So if I ask you to convert, like we did earlier on, I said convert 450 meters to kilometers. 450 meters to kilometers. Take note, from meters, I'm going to cross over many tens. Check the number of tens. I'll pass this 10. I'll pass this 10. Sorry, and then this stick there. Remember that's the meter. I'm going to pass from here, I'm passing 110, another 10, and what now? To get what? So, kilometers. I pass how many times now? 3 tens. So, 10 times 10 times 10, we give me what? 1,000. That's the conversion factor from what? From meters to what now? To kilometers. Is that okay? So, I'm going up. So, what do? I'll divide it. I'm going up now. So, I'm going up by what? I divide. Is that right? So, I'll divide by what now? By 1,000. I'm going to have 450 divided by what? 1,000. So give me what? 0.45 kilometers. Is that okay? If I'm converting the same for 42 meters, I want to convert from 2 meters to what now? To decimeters. And then to centimeters. Then to what now? Millimeters. Question is, from meter to decimeter, how many times do I pass? Just one, right? From meter to decimeter, I pass only one word now, 10. That is conversion factor is what? Is 10. So I'll have 42 times what? 10. Why is that? Because I'm going what? Down. That'll be what now? 420 decimeters. If I'm converting to centimeter, from meter, I'll pass how many 10? 2 tens. Can you see that?
Yes.
I'll pass this 10, and I'll pass what now? This 10. So 10 times 10 will give me what now? 100. So my conversion factor from meter to centimeter is 100. Alright? So I'll have what now? 42 times what? 100. So give me what now? 4,200 centimeters. Obviously, to get to what? Decimeter, to millimeter, I'll pass how many 10? 3. That is 1, 2, and 3. That'll be 1,000, right? 10 times 10 is 1,000. So I'll have 42 times what now? 1,000. So give me what? 42,000. Thank you very much. 40,000. The same thing applies to what? To mass. If you're converting, conversion factor is what? It's 10. However, for time is different. For time is what now? It's different. For time I'll be converting, let's say I have 3 hours and I want to convert what? To seconds. 3 hours to seconds. So we start from what? From hours to minutes is what? 60. From minutes to seconds is what now? Another 60. 60 times 60 is what now? 3,600. So it's going to mean I'll have 3 times what? 3,600. 3,600 will give me is that? Please confirm that that's correct. Will give me 108 what now? 10,800 what seconds. You get it? So 3 hours is equivalent to what? 10,800 what seconds. Is that correct? Okay, good. Now, if I was converting, let's say I'm converting 240 seconds to minutes. I want to convert 240 seconds to what now? To minutes. I'm going what? Up. So what do? I'll divide it. And then I'm crossing what now? Just 60. So it's going to be what now? 240 divided by what? 60. So give me what? 4 minutes. That means what? 240 seconds is equal to what? To 4 minutes. Is that okay? Basically, that's how we'll convert. Then this one is easier because all of them are linear. Even for capacity, capacity is also linear. Take note of that. Capacity follows the same order. If I have capacity is going to be what? There's liters, then there's what? Decimeters, there's what? Centimeters, or what? Milliliters. If you check your syringe for injections, what you see 5 ml. If you check your drinks, sometimes you see what now? 50 cl, 30 cl, and all that. So you see 450 what now? ml, milliliters. Do you understand? If you check your juice, you see 1 liter, you see 1 L, right? The same order that this one is following. Sorry. It's 10, and it's what now? It's 10. Like the other ones. Do you understand this? So I'm leaving here now to go to something a little more challenging for area. Area is 2 dimension. All we have been doing since that what now? 1 dimension. So in case of area, I'll have what? Meter square. Are you with me? Then I'll have what? Decimeter square. I'll have what? Centimeter square. And I'll have what? Millimeter square. Up I'll have decameter square.
Yes.
I'll have hectometer square. And how about kilometers? And because it is two-dimensional,